Hello again. We're still doing the thing where we build redox tables, and many of these use real elements, so yeah, we could probably go look all these up, but pretend that you can't so that we get good at the actual skills here. Each of these is a situation where a more positive element, typically, or a more positive species, is going to see something more negative and say, I could steal electrons from that. And then it tries to, and the question is, does it succeed or not? If there's a reaction written, it means, yeah, it did. Here, cobalt tries to take electrons from zinc, and it did. Cobalt's charge went down, which means it gained electrons and was reduced. Zinc's charge went up because it lost electrons and got oxidized. From that, we would conclude that cobalt is better at fighting for electrons, and if we were making a redox table, we would rank cobalt higher than zinc. Okay, so very short version. Cobalt tried to take electrons from zinc and succeeded. Cobalt is tougher than zinc. Next reaction, the more positive thing, magnesium tries to take electrons from zinc and fails. If there's no reaction, it means zinc said, no, I don't think so. That would imply magnesium is weaker than zinc and should go down here on our list. So these are rankings, and at the top are things that are really good at fighting over electrons, and at the bottom are things that are really weak and usually lose fights for electrons. But this is not a redox table. If we want the table, we have to write it like in our data book, where you have positive things on the left plus electrons, arrow, and then the more negative version. So our cobalt entry would be cobalt 2, Y2, because it says over here, gains 2 electrons that it wanted and turns into cobalt metal. Then we'd have zinc, which starts as zinc 2, gains a couple electrons, converts to zinc metal, and at the very bottom, magnesium gains 2 electrons and turns into magnesium metal. Now, like in our data book, in this box we have our oxidizers on the left with our strongest oxidizer, cobalt ions, in the top left corner, and then things get weaker as we work our way down until we get to our weakest oxidizer, magnesium. Yikes. You should have stopped me there. Magnesium 2 is our weakest oxidizing agent. And going up the right side, we have our strongest reducer, magnesium metal, in the bottom right corner, working up to our weakest reducer in the top right. They can ask for any of these. They can say, what's the weakest reducer, what's the weakest oxidizer, what's the strongest OA, what's the strongest RA. They can say, give the reducing agents in order from weakest to strongest or strongest to weakest, any of that. Those questions are really hard to answer if you don't have the table laid out nice. So my advice would be lay out the table nice. Do it just like in the data book, like this, and then you're ready for any question they ask. In this case, they say, what are the strongest oxidizing agent? Answer, cobalt ions. And what's the strongest reducing agent? Answer, magnesium metal. Also, please notice, say ions or say metal. If you answer this question by saying cobalt and magnesium, you don't deserve all the points, because those are not the same thing in electrochemistry. Be specific about whether you mean ions or uncharged metals. That's something we can expect of you without reminding you about it at this level. Okay, let's do a couple more reps of that. I'll try to pick up the speed. Beryllium meets cadmium. This is the more positive thing. So cadmium tries to take electrons from beryllium, and it did. Cadmium is higher ranked than beryllium. Next row, hydrogen tries to take electrons from cadmium, and it does. Hydrogen is even higher than cadmium. Calcium tries to take electrons from beryllium and can't do it. Calcium loses to beryllium. It's lower yet. And hydrogen tries to take electrons from copper. Remember, it's always the more positive thing. Or as a rule of thumb, it's the more positive thing that's trying to take from the more negative thing. Hydrogen tries to take from copper and can't do it, so hydrogen must not be as high as copper. Copper is at the very top. So there's our ranked list. And guess I'll break my page layout if I try to drag that. I'll just have to rewrite it again carefully. So our redox table is going to look like the copper line is the top. They never do say what copper's charge is, but we'll go with the one that's in the data book, even though there is such a thing as a copper 1 ion. Then we get hydrogen. La 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 la. Turns into hydrogen gas. Then we get cadmium. Turns into cadmium ions turn into cadmium metal. Then we get beryllium ions. Turn into beryllium metal. And at the very bottom of our table, calcium ions convert to calcium metal. The strongest oxidizer would be copper ions. The strongest reducer would be calcium metal. And can we do one more? This time it's made up elements. Okay, this has charge in -1 and this has charge 0, so this is the more positively charged thing, so to speak. Y tries to take electrons from X, and it did. Y is ranked higher than X. Y tries to take electrons from W and can't do it. No reaction. So W is higher than Y. And X tries to take electrons from Z and succeeds. X is higher than Z. So that's our ranked list. If we make that an actual redox table, our W line... Now, because these are made-up elements, I'm going to have to try to figure this out. W is either... Boy, they never say what W is. All these other things are diatomics. They're talking about them like they're oxygen or nitrogen or fluorine or whatever. So I'm going to make a kind of wild guess that the W is either this ion or W2. Am I sure about that? No, but I have to write something. Sorry. So I'm going to say the W reaction is W2 gains 2 electrons and turns into 2 W minus ions. Next one would be Y, which same sort of ions. It's diatomic, then it gains 2 electrons and turns into 2 single charged ions. Then we get X, same structure again. Diatomic molecule picks up 2 electrons and turns into 2 negative ions. And finally Z, same thing. This is the kind of table you'd get if you ranked like fluorine, chlorine, bromine, and iodine, where they're both diatomic, they both form negative ions, and they're even in the order that I said. So our strongest oxidizer, top left, would be W2, and our strongest reducer, bottom right, would be Z minus ions. No need to put the 2 here. It's the ions themselves which are a strong reducing agent. It isn't really relevant that they react 2 at a time.